All right, so I've done several examples already, so we're going to do number 3 here, and I want you to work on this one on your own. So go ahead and pause this video here and work through this number 3 example. All right, so let's talk through this one. You can check your work as we go. All right, so starting with number 1, all right, we always want to verify that NP is greater than or equal to 5 and NQ is greater than or equal to 5. So let's go ahead and identify those values as well. So our N is our sample size at 2,202. Our P is given to us at 0.51. Our Q is then 1 minus our P, so we're at 0.49. And then our P hat is taking our value of 1,161 that say they're effective against viruses and dividing it by our total sample of 2,202, giving us the 0.53. All right, so we substitute those values in. We can see for NP that 1,123 is greater than or equal to 5, and that 1,079 is greater than or equal to 5 for our NQ. So then step 2, we can then identify our null hypothesis, which is P equals 0.51, and our alternative hypothesis, which is P does not equal 0.51. That is also our claim, because we're talking about those who incorrectly believe, and we have a two-tailed test because this is an equals to and then not equal to. Okay, from there we then want to find our Z using our formula there, substituting those values in, and you get a 1.88. It's going to be two-tailed, right? So we're going to have a negative 1.88 Z-score and a positive 1.88, which you see in step 4 with our sketch there, and we go to find our P. From that, you can take that and use Staplet to figure out those values. So going there, our mean is going to be 0. Plot our distribution. We want outside of a region, and so we are negative 1.88, and our right boundary is a positive 1.88. We calculate, that gives us our 6.01 or 0.06, which is what we have there for P. And then since our 0.06 is less than our significance level of 10% or 0.10, then you reject the null hypothesis. Which then brings us to the summary of all of this. So we can state that there is enough evidence at the 10% level of significance to support the claim that 51% of U.S. adults believe incorrectly that antibiotics are effective against viruses. Okay? Now, if we had gone to the 5%, then this wouldn't have worked. And so it's enough evidence at the 10% level. That can change depending on your significance level there. All right, which brings us to number 4. And so what I want you to do here is you're going to work through this one again on your own, but this time, no answers here. You're going to be expected to, as a group, do this problem on the board when we come back in class together.